All right, in this video, we're going to learn to identify parts of an expression using math terms, and then we're going to simplify expressions. So this is our example that we're going to use over here as we explore the vocabulary words related to expressions. So a term is a single number or the product of a number and a variable separated by an addition or subtraction sign. So let's break that down. So a single number, oh, I see my 3 is a single number. That's a term. A product of a number and a variable. Well, 3x is a product of a number and a variable. So is 4y, and so is 4x. Those are all terms. And I noticed too that they're separated by that addition and subtraction sign. A variable is just a letter that represents an unknown number. Okay, and so we have two different variables, a y and an x. Those are not the same number because if they were, we would only have one variable in this expression. But I do see that there's two x's up here, and both of those x's would represent the same unknown number. Now we've got a coefficient, which is a factor multiplied by a variable. And we have a few different examples of those. So the 3x, actually, sorry, I'm going to scoot that over here. The 3x is an example. The 3 itself is the coefficient. So that also means that this 3, this 4, and this 3 are all coefficients. I always struggle to spell that. Okay, and then a constant is just an algebraic expression, a term that does not change its value. It contains no variables. So we've got one of those, and it's our 3. That's our 3. Okay, and then finally, like terms are terms with the same variable raised to the same power. Okay, an example of that would be 3x and 4x. Okay, they have the same letter or same variable, x, and they're raised to the single power, or to the power of 1. And so there's just 1. And so we could do what's called combine. And that's the whole reason we're getting to know this, is because we want to take an expression like the one down here, 4ab plus b minus 3ab plus 5b, and we want to simplify it by combining like terms to get a simpler, smaller expression. So let's explore what terms are similar here, or like terms. So right away I see I've got a b and a 5b. Notice that I'm getting the sign with it, okay? Because that matters. That means these are 5 positive b's, or I'm going to add 5b, and here I'm going to add 5b, or think of it as positive b's. Now, I notice an AB and a BA, and I'm asking myself, are those the same? Well, let's explore that for a second. Versus, okay, and if you keep in mind, let's just say for a minute that A equaled 1 and B equaled 5. If that was the case, then it'd be 4 times 1 times 5, which would be 20. Or 4 times 5 times 1, which would be 20. So these actually do work. We can change the order, and the property that tells me that is the communicative property. I can never say that straight. And that just means we can change order when we're multiplying. Okay, we can also do that in addition too. All right, so let's see here. So let's go ahead and highlight those because, yep, we just discovered they are indeed like terms. And now let's go ahead and combine them. So we've got 4ab and minus or a negative 3ab. So that means I'm going to be left with 1ab, and I don't need to write the 1 because I can see that I have 1ab. Okay, if there's no letter or there's no number in front or a coefficient, we assume it's 1. Now, I've got positive b and a positive 5b, or I need to add 5b to b, so I get 6b. That's our simplified version of the expression. Now, we call that the standard form of it. And what we're going to do is we're going to justify whether that worked or not, or why that works. So if I write down my original expression here, And remember, the variables stand for an unknown. And I'm just going to select what I want that unknown to be. So I'm going to say A is going to be 2. B will be 3. So every time I see every time I see an 8, I'm going to replace it with 2. Every time I see a B, I'm going to replace it with 3. And I'm going to use parentheses to show multiplying because it helps me just keep track of replacing. I can see if I made an error kind of more quickly. Okay, 3, and then I need a B, which is 3, times an A, which is 2, plus 5B, which is 3. Okay, that's a big one. Okay, so now we're just going to go through. 4 times 2 is 8, times 3 is 24. And then I'm just going to rewrite. Okay, and then that's adding. This is subtraction. So then I'm going to go to multiplying these 3 in the middle here. So 3 times 3 is 9, times 2 is 18. So notice I'm following my order of operations. Okay, and I'm just going to cheat and do 2 steps in one. 5 times 3 is 15. Okay, now I've only got addition, so I'm going to go ahead and do that. So 24 plus 3 is 27, minus 18 plus 15. 27 minus 18 is 9, plus 15 is 24. Okay, now if I simplified correctly, I'm going to get the same answer when I use my simplified expression. I need to, though, use the same value for A and B. So A is 2, B is 3, plus 6, and then my B is 3. So 6 plus 18, and guess what? I get 24. So these are indeed equivalent. So again, standard form is simplifying it by combining like terms. That often helps us get an expression in its simpler form, or sometimes solve it more efficiently as well, or an equation more efficiently as well. Thank you for listening.